Hey, good evening, friends. Today we are going to talk about the isolation forest. The isolation forest is basically used for the anomaly detection. What do you mean by anomaly detection? Anomaly is a point which is different from the general data which is present in our data set. Okay, so we can clearly identify that the anomaly will be a data which will be rare from the other data points. So what will happen in the isolation forest? What we do is, instead of focusing on the points which are general, we focus on the points which are going to be anomaly. So we do not have to do the extra step of first considering the general point and then identifying our anomaly point. Now what happens is that what we do here now what happens here is that now what we do, we make the isolation trees. That is, we have already studied the decision trees. So what we do is, like, we decide a feature on which we are going to split our trees, and we take a value, threshold value for that particular feature, so that we can make this separation. So what will happen is that if the data will be normal, then we will be requiring more split in the tree. But if the data is an anomaly, it will be separated with minimum number of split. That is, it do not cover the more depth. Okay, like suppose I have been given a data point 1, 2, 3, and 10, and I just decide to make a threshold value for 5. So all the values which are greater than 5 will come here, and all the values which are less than 5 will come here. So 10 will automatically come here. So in one split only I am able to get my anomaly. That is different. Like here, see, these are 1, 2, 3. These are close and related to the 10 is a different value. So in one split only I will getting my 10. Now what we will do is, we will find the going to get the formula to find the path length through anomaly score. Okay, we are going to get what anomaly score by using our path length. The formula here is very simple. That is, the anomaly score, that is, as for a particular data point x and normalization factor n, 2 to the power e minus hx divided by cn. So what is here our e of hx? Now what happens is that we do not only make one tree, we make multiple trees. Okay, now suppose there was a point x. Okay, so in the first tree I was able to get it in one split only, but in the second tree I have to do two split. In the third tree again I get it in the one split. Okay, so average value will be taken 2 plus 1 3, 3 plus 1 4, 4 divided by 3. Okay, so e of hx is nothing but the average of the depth of the particular data point x in all the isolation trees present in our isolation forest. Okay, and what is our cn? Cn is nothing but a normalization factor. We just divide the value that came after averaging with the cn, because this value might come more also. For example, if we will take it for a normal value, then the value may be large. So what we do is, to minimize their value between the 0 to 1, we just divide it by a normalization factor. And if my s of x, that is the anomaly score for a data point, is coming out to be 1, then it will be considered as anomaly. And if score is coming like 0.5 or something, then it will be considered as a normal point. Thank you.